Welcome to my channel, and I hope watching my video will not be a waste of time to you. So please stay tuned and watch to the end. I hope by the end of this video you will learn derived units. When you talk of measurements in physics, you are talking of fundamental quantities, derived units, and others, because from here we have the primary knowledge that you need when measuring. So under derived units, I have that derived units are units that depend on the fundamental quantities. So derived units can also, you can say that derived units are formed from fundamental quantities. They are like combination of some of fundamental quantities. So by this definition, I hope you have like a little knowledge on what we are about to do. So I have some examples of derived units. I have my first one, area. And area, when you want to measure something, area, it means two lengths, two or more. So when you're trying to measure area, you try to measure from here to here and from here to here. So that is the reason why area has its unit as meter square, because you try to measure two lengths. And by measuring two lengths, you are trying to do something we call multiplication. This length times this length. So area by definition, by multiplying two different distances. Like you have the length here and the breadth. So by multiplying the both, or sometimes in meter. So by multiplying the both, we have that 15 cm times 6 cm. So from this multiplication, you have 15 times 6 gives us 90. Then in cm square, because the both are in length. So length times breadth gives you area. Sometimes they will give you two lengths, so you can also multiply the both lengths and also have your area. So from the multiplication, you convert or you change to the SI units. And by SI units is a system, is the principal system for measurements. So in measurements, you have to maintain the SI unit for an accurate readings. By measuring area, you have to convert it to its SI units. So SI units of area is meter times meter gives us meter square. So when you see area, know that the unit of area is meter square. From our calculation, let's try to convert this 90 cm to meter and see what it gives us. From our meter rule, we have that 100 centimeter is equal to 1 meter. So trying to substitute 90 cm to find its conversion to meter, we apply the cross multiplication method. Our meter rule tells us that 100 centimeter is equal to 1 meter. But when you are working with area, or when you are trying to calculate or convert area to its meter, especially when it is calculated in centimeter, you have to observe the squares. So this is the normal meter rule scale, 100 centimeter equal to 1 meter. But since the centimeter is in square, representing that this is area, so you have to know that 100 centimeter times 100 centimeter is equal to. So this is simply what we have. We have that when 100 centimeter times 100 centimeter, we have something like 100 multiplied by 100 is equal to 10,000. So it means that 100 centimeter to 100 centimeter square means 10,000 centimeter square. So to a simple conversion, we say that 10,000 centimeter square is equal to 1 meter square. So you begin your conversion. We place our 90 cm square. Let's use S to indicate our missing variable. So from here, we cross multiply. From a cross multiplication, we have, so this is what we have. What are we looking for? We are looking for S meter square. So making S meter square the subject of the formula, we divide by the coefficient of S meter square. So dividing both sides by the coefficient, we have that. This is what we have. The next thing you have to do, you cancel here, because they are both the same thing. So we have that S to meter square is equal to 90 meter square multiplied by this divided by this, or you can simply do cancel cm square, cancel cm square. So 90 multiplied by 1 meter square divided by 10,000. From here we have 0 cancel 0, S meter square equal to 9 over 1000. From here, you can leave your answer in standard form or in fraction form, any form you like. Let's try converting this to its standard form. We have s to the equal to, how many zeros are here? 3. So the 3 zero means 0.00. So this is what the 3 zero simply means. So 0.009. Or you can try doing so it depends on the form you try to leave your answer or you wish to leave your answer. So from here we have that the area of 50 cm by 6 cm gives us 9.0 times 10 raised to power minus 3. The next one, we have volume. And in physics, we calculate volume as length times height times breadth. So length times height times breadth are both measured by a distance. So it gives us the SI unit of meter cube. Meter cube. So this is what volume gives us. And so by a practical example, we say that volume is a space in a container or in a given material that is occupied by a substance. That is the definition I can give you now. So by this length times breadth times height, we say that if this thing should be a vessel and you are asked to calculate the volume of liquid inside this vessel now, you calculate the length, the height, and the breadth. So from this calculation, you have that volume is measured in meter cube. Then the next example, we have the density, and we say that density is the mass per volume of a given substance. So you can define it in your own term, but in density, you have to know that two things are applicable. You have to know the mass and the volume. So by this definition, you will notice that this thing is like in a container. The container has a certain volume that the substance occupies, and the volume has its mass, like it has a weight. So from here, we have the derived unit as density equal to mass over volume. And mass over volume, we have the derived unit as mass. We have the derived unit of mass as kg, and the derived unit of volume in meter cube. So from here, we have that density is measured in kg per or kg meter cube raised to power minus 1, depending on the form you want to write it. So this is what we have for density. Then the next one, we have velocity. By velocity, we mean displacement over time or displacement per unit time. So by velocity, we mean an object, let's assume a moving vehicle, a lorry for instance. We say that this lorry is moving in a velocity of, by that we mean the displacement at each particular time. So from here it may displace to, okay, let's first of all observe the cardinal points: the east, the west, the north, and the south. So from displacement, we may say that the lorry displaced from, it was moving something degree east now, for example, and at a certain distance is displaced to something in degree to east or north or south, anyone. So the displacement now is from here to here, from here to here. We calculate it as velocity. So velocity is the displacement per time. So we have the units as displacement over time. We say that time is measured in seconds and displacement in meters. So we have meter per seconds, and that is the unit for velocity. We have another one, acceleration. We say that acceleration is the change in velocity per time. So by acceleration, we mean when the velocity, we calculate the displacement per time, then we say that the velocity now per time. So we can say that it's either you say change in velocity or you say velocity over time. And velocity is already measured in meter per second. So it means that the unit of acceleration will be meter per second square. So this is what we have by substituting the velocity by the extra time due to the acceleration. So we have the next example. We have force, and we say that force is mass times acceleration. When you hear of force, you will notice that force means that there is a substance. This substance does not have enough mass for me to apply too much force. So by force, we notice that there must be a mass. The material, the substance must occupy weight, like it must be a property of matter. Then the next thing, that for there to be force exerted on this substance or on this material, it must make a move. So the move now, we use acceleration, because by force you may push, and due to the substance or the material does not have too much weight occupied in it, so you may push and it will move to a distance that you may not even expect. That is the reason why we say that when you apply force, you make a move called the acceleration, and the material or the substance has weight. So that's the reason why it is calculated by mass times the acceleration. So from this, we measure force by the units of the both derived quantities, and the unit of mass is kg, kilogram, multiplied by acceleration, which is meter per second square. So by the two multiplication, we have, so from this we have kg meter per seconds, and we have a word we use to represent the unit of force, and that is Newton. So anytime you are asked to calculate anything in force, or you are asked to find the force exerted on a material, then you know that your unit will be in Newton. So the Newton now is spelled as W-E-N-T-O-N. So this is Newton, and this is the unit of force. The next one I have energy. And energy, we define energy as force times distance. Energy, force times distance. So by energy, they mean not energy by electric current, but energy we mean here, we mean energy by your human strength, energy by the strength of a machine, of a body, of a system. That's the energy we are talking about. And for you to show your energy, you must apply force, and your force has to make a distance. So by the multiplication of the both, we have energy, and we say that energy is measured in joules. Let's try putting something down on our paper. So this is what we have by energy, and we say that energy is measured in kg meter square per seconds square, or you use a word joules, and joules is spelled as Joules, joules. The next one, we have power, and power is work over time. Work or work, anyone you try to call it, just know that it is either you call it work or energy. So it's work over time or energy over time. So by energy over time or work over time, know that when you talk of power, you are trying to talk of what you are capable to do at a given time or a given time interval. So let's take, for example, two men are asked to cut a field. The first man may cut the field at 2 minutes. The second man may cut the same field, the same portion of land, at 5 minutes. So from the both men, we say that the man with the higher power is the first man that cut the field at 2 minutes. So it simply means that when you're talking of work, we are talking of something based on time interval. Two men are given the same time to do the same work, and the person that do the same work at a shorter time, we say that the person has more power than the other man. Or in industry or in factories, we say that a machine that has a higher power is a machine that can be capable of doing a work at a shorter time. Let's assume the plastic industry. A machine may be used to cut the plastics, and the machine that cuts the plastic in a shorter period of time than the other machine that will cut the same plastic at a given time, we say that the one that cuts within the shortest period of time has more power than the other that waste time in performing the same work. So from this, we have to put that work over time, whereby work has its units as joules and time has its SI units as seconds. So from this, we will say that power is joules per seconds, or you use a word watt. The next one, we have momentum. By definition, we say that momentum is the multiplication of mass and velocity. Mass, velocity. Momentum has several definitions based on the context you are using it. So, but in this now, we say that momentum is the quantity of movement of a moving object. That is the mass multiplied by the velocity, or you can say the speed. So this is to tell you that it is like the ability of increasing or keep developing when an object is in motion. So momentum, we say that momentum is the mass multiplied by the velocity. Momentum, an object that is in motion, has mass, and its momentum is based on the speed. So we say that the mass times the speed, or the mass times the velocity, we have momentum. So from mass and velocity, we have their unit to be that mass is measured in kg, kilogram. Then you multiply by the unit of velocity. Velocity is displacement over time. So velocity, we have meter per seconds. Combining the both now, we have kg, meter per seconds. Another thing you have to note is that momentum has its sign or its symbol as small letter p. So from here, we have the next one as pressure. So by pressure, you will note that it has a simple or a practical example. Let's try applying this in a fluid statics. Like in physics, there is a topic we called fluid statics. In pressure, we have a practical example, and for you to observe that, you bring a vessel that has at one end a larger opening, at the other end a smaller opening. Then you place something that you can use to compress the liquid inside the vessel, or the fluid inside the vessel, so that when you compress at this end, it will move to the other end and comes out, or it moves to the other end and flows out. So from that, you observe what is called pressure. So by definition, we say that pressure is the force you apply all over the area. So from here now, we say that for us to find the units, force is measured or has its unit as Newton, and area has its units as meter square. So from here, we have that pressure has a unit of Newton per meter square, or you can use a word called Pascal, and Pascal is a unit of pressure. I hope you have learned something from this video you have just watched now, and I hope you may have some questions to ask. Please ask your questions on the comment box you see below this video, and please, if you are new to the channel, please hit on the subscribe button and click the bell and turn all notification. You will see all, personalized and none. Please click on all so that we get all notification from our updates on this channel. See you on our next video.